All right, here we're going to look at graphical reasoning and what we can learn from graphs. So if we have graphs that involve forces, distances, energies, times, etc., etc. And this is somewhat of a generalizable concept, but we'll talk about the specifics of how it relates to energy as a unit here. So, graphical reasoning. The things that we want to consider are twofold. We want to look at slopes and areas. So if you have a slope, that's essentially change in y over change in x. So if you're looking at a graph and you think, okay, on the y-axis I have, for example, position, and on the x-axis I have time. Well, we know that change in position over change in time is a velocity, and that's why we said the slope of this curve is velocity. We'll talk about some examples for energy in a second, but just kind of keep that in mind that we're looking at that. Now, areas are functionally the change in x times the change in y. So if something where you'd multiply the x times the y and get some kind of relationship, that would be our area. So for example, something like this, and if this is time and this is velocity, well, we know velocity times time gives us a position. So the area under that curve would represent a change in position. So some examples. Let's look at and think about equations that we have in this unit. So work equals F times delta X. We have UG equals mg delta H. That's not going to be something that comes up, so let me erase that. Whoops. We have power equals work over change in time, or change in energy over change in time. And we can rearrange a lot of these equations as well. So force is equal to work over change in x. Power times change in t is equal to work. So now you see we've got all these relationships. This is a slope. So the slope of a work versus change in distance graph, the slope of that graph would be your force. This is an area. So the area under a force compared to delta x graph would be work. This is another slope. So the slope of a work versus time graph would be the power. The slope of an energy versus time graph would be power. This right here is an area. So the area of a power versus time graph would be work, etc., etc., etc. So this is what I want you to be thinking about going forward, is anytime you've got a graph, just compare the two axes. If the area looks like a function you're used to, then that means you can find the, whatever that extra value is. If the slope, compare the y over the x, looks like something you've used to, then you can use that to find that value. So again, you're mainly looking at stuff like this for your example. This isn't everything, this isn't all the possible ways we could do it, but it's a couple examples to kind of get you started and thinking about them.